Hello everyone, good morning. You're welcome to the science class for Basic 6. This is our first lesson for the third term 2021 academic year. This lesson, we want to do a quick recap on what we learned before the break came up, and also continue and complete it as well. Before the break, we started with electricity and electronics, where we learned about electric circuits and the various components that make up electric circuits. We learned about bulbs, diodes, resistors, capacitors, inductors, electric wires, and the like. But it was kind of unfortunate we couldn't finish up, and we want to proceed on and finish up before we take the next sub-strand. It's actually another strand, force and energy. So we have other sub-strands that we need to look at before we move on to the next strand. Now, in this lesson, we want to look at electrical conductors, semiconductors, and electrical insulators. As we learned previously about electricity, and that we need a circuit, or we need a path through which this electricity or electric current can flow, so that we can get it to the various destinations, or we can get electricity to power up our electric appliances or electric gadgets. And we also learned that before we can get the electricity generated, we need to get a medium through which electric charges can flow. And these media are scientifically known as electrical conductors. These are the materials that allow or easily allow electricity to flow through. Why are they able to do so? Because these special materials have free electrons on their surfaces, and we learned that electrons are the electric charge carriers. These electrons are the carriers, are the vehicles that can move electric charges from one place to another. So electrical conductors have been designed in such a way that they have these free electric charge carriers, the electrons on their surfaces. So as soon as it is connected to an electrical source, you can easily move those charges and get them to our desired destination, or get them to empower our electrical appliances in our homes, our factories, industries, schools, and the likes. Now, we want to know about some of the examples of these electrical conductors. We have brass, we have tin, we have gold, we have copper, we have aluminum, we have human body, we have plants, we have animals, we have impure or ionized water. Why am I mentioning all these things? In general, all metals are electrical conductors, but it's not only metals that can conduct electricity. We have also human body that is able to conduct the electricity. That's why when you touch a naked wire, you get shocked or you get electrocuted if God does it in a vein. Why? Because this human body also is full of ions, which are able to move or which are able to conduct electricity to the various destinations. So once you touch a naked wire, or you touch an electric source, these charges can easily move through you because you have these ions, and we have also water full of ions in our body. So we become a good conductor for electricity. In the same way, plants, animals, and all the living cells, living organisms that you can think of, these are all having ionized water in them. Water that contains ions, which enables them to easily conduct electricity and move electric charges from one place to another. Also, we want to look at electrical insulators. Electrical insulators actually act in opposite to electrical conductors. For these insulators, they are the materials that do not allow electricity to flow through them. Why are they not able to conduct? Because these materials lack the electric charge carriers, the electrons on their surfaces. Because of that, if you connect to the biggest source of electricity, they will still not be able to conduct. That is why we have. That is why engineers always use plastic casing or rubber casing on every wire. They use it to wrap every electrical wire, because they know that these casings are insulators, and once one accidentally or mistakenly touches them, it can't shock the person, because the electric current flowing through the wires, the copper wires or the silver wires, cannot move through these plastic casing or the rubber casing. And because of that, we are able to use them, and they are harmless to us. We have examples of these insulators that we want to look at. One, we have wood. Woods are insulators. Wood do not allow electricity to pass through them because they lack electrical charge carriers. We also have plastic. We also have glass. We also have rubber. We also have deionized water. That means water without any ion. Or we can say pure water. So we have a lot of them that I have actually included in the notes, the lesson notes I have uploaded on the platform. So you can go there, read through, and also I will also urge you not to limit yourself to only that, but to research and get more info, so you can get many questions and ask me on the platform, which I will soon answer. We also want to look at another special group of materials that we call them semiconductors. These are unlike conductors nor electrical insulators. These are the materials that are able to conduct electricity only to some extent. They can conduct more readily than electrical conductors. In the same way, they can conduct less. They can conduct less. They can conduct more readily than insulators, but less readily as compared to that of conductors. Why? They have a considerable electrical resistance in them. But for electrical conductors, they have little or negligible resistance, so electricity can easily map their way through. But for semiconductors, they have a considerable resistance, which needs to be overcome in a way that we have what we call a barrier, a p-n junction barrier. Before we get semiconductor constructed, we have the positive type semiconductor. We have a positive type semiconductor. We bring it up together with what negative type semiconductor, so that we can form a diode, which is used in almost every electrical appliance. But once this diode is formed with these semiconductors, we still have to break this barrier which has been created between the positive type semiconductor and the negative semiconductor. So this is the considerable resistance I'm talking about. We can only get this one conduct as a conductor if we connect it to an electric source. That is, if we dope it, we have a term called doping. If we bring in more charges, then these charges will be able to break through that barrier, and then that have their easy way out. In the same way, if you also increase the temperature of the semiconductor, you can break the barrier as well. Now, we have examples of these semiconductors. We have silicon, we have germanium, we have gallium arsenide. These are special materials that are able to conduct electricity to some extent. And you can conduct easily or readily if only we connect it to an extra electric source. Or if we increase its temperature, you can easily conduct as if it were a semiconductor, a conductor. We have differences between conductors and insulators. We've already learned about them. How different is one from the other? For the electrical conductors, they have free electrons, as I've mentioned earlier on. They have free electrons, that is the free electric charge carriers. Because of that, they're able to conduct electricity or move them from one place to another, electric charges. Now, for insulators, they do not have, because of that, they are unable to conduct electricity like conductors. Also, for conductors, they have little or negligible amount of electrical resistance. Because of that, there is nothing so strong to oppose the electric charges as they flow. But for insulators, they have great or extremely high electrical resistance. Because of that, they are unable to conduct electricity, because this particular resistance will not allow the charges to flow. Also, for the electrical conductors, they are mostly metals, but for the insulators, they are non-metals. So I would like to end here for lesson 1, and I'll urge you to ask all your questions on the platform. Do not hesitate to ask any question. I urge you also to read other materials, Google, get more information, and I've also attached homework, and I know you will see them and do them as soon as possible, so that I can mark and get a feedback. I'll see you later. Bye bye.